Hey guys, welcome to lesson 3 of unit 11. Our topic today is related rates and triangles. I want you to pause the video and try the question. You can use the calculator for this question. Okay, so it's saying a ladder 25 feet long is leaning against a house forming a right triangle from the ground. So we have a right triangle, right? And that's my ladder. The hypotenuse of the right triangle is my ladder, which is 25 feet. Let's start label. This is a right triangle. I'm going to label my horizontal distance as x. This is y, and I'm going to say my z is 25. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. So can I say my dx over dt is 2 feet? Because what's happening, the distance as the ladder is pulling away, my horizontal distance is going to increase. So it's positive 2 feet per second. Now it's asking how fast is the top of the ladder moving down the wall when the base of the ladder is 12 feet from the wall. So when my x is 12, how far is the ladder moving down? So I basically want to find dy over dt. But I don't even know my y, right? But since it's a right triangle and I know two sides of my right triangle, can I not find the third one? So I'm going to write my equation, my Pythagorean theorem, equals z square. I know my x square is what? 12 square plus y square equals z square, which is 25 square. If I solve for y, you can do that math. I get, always round to 3 decimal places in this class, guys, 21.932. Okay, so I know that I want to find dy dt. I also don't know dz dt, but just think about it. Would the size of the ladder, no matter where I place it, would it change? No. So my dz dt would be 0. So that is something that you need to pay attention to, since the ladder is not changing the length or increasing or decreasing. So my dz over dt would be 0. So now I'm going to use the same equation. I'm going to actually change colors. Y square equals x squared plus y squared equals z squared. And I am going to take the derivative with respect to what? Time. So it's going to be 2x dx dt plus 2y dy dt. I'm going to zoom in so I have more room here. Equals 2z dz dt. Right? I'm going to just substitute everything into the equation. You can either choose to solve for dy dt, but I just like to substitute in. So I know 2 times 12 times dx dt is 2. Actually, can I not factor out my 2's? I'm going to cancel these 2's. So then it's, right? If I factor out the 2, these 2's actually cancel out. If you're not sure, let's do that another step. So I'm going to actually show it to you so that we're careful. So I factor out 2, I'm left with dt plus y times dy dt equals 2z dz dt. Right? I'm going to divide by 2 so that 2's cancel out. So basically your 2's canceled out. You didn't have to do that extra step as long as you understood it. I'm going to take it here and just sketch a line. Right? So now what is my x? My x was 12. My dx dt was 2 plus y is, we found it to be 21.932 times dy dt equals z is what? 25 times 0. dz dt is 0. Right? So now if I want to solve for that dy dt, I have negative 24 over 21.932, which is, put that in the calculator, negative 1.094 feet per second. Okay, So if it's a right triangle, again, just remember, we are going to be using the Pythagorean theorem. If they are one of your triples, you don't even have to show that work, but here you need it to. Now it's asking us, find the rate at which the area of a triangle is changing when the base is 12 feet from the wall. So the area of a triangle. First of all, I'm going to sketch my triangle again. So the area is changing when the base, which is my x, or I can say b, this is 12. I already know my dB dt if I was to talk in terms of, so it's 1/2 base times height. I'm going to write it in terms of actually x and y, so that way it's easier and we don't have to x times y. My base was x, so x is equal to what? 12, right? And my y is what? We found that 21.932. Okay, so now I'm going to take the derivative. We're going to use the product rule here, which is a prime b plus ab prime. So dA over dt is equal to 1/2 y, or I would say 1/2 dx dt times y. So it's easier for us. So this is actually your a prime. Plus a is 1/2 x times derivative of y is 1, but I'm going to do dy dt, right? So all I need to do is now substitute everything in. dA over dt equals 1/2 dx dt is, what did we get for dx dt? It is 2 times y, which is 21.932, plus 1/2 x is 12 times dy dt. I got negative 1.094. Put that whole thing in the calculator and I get my d over dt is 15.368 feet square, per second. Okay, again, it's not asking you for the units, but it's a good idea to practice your units. So very similar to what we've been doing, but now we're using the triangles. Okay. Example 1. So let's look at this. A small balloon is released at a point 150 feet from an observer. So let's say my observer was here, 150 feet away. They released a balloon, and the balloon's going to go straight up. Who is on a level ground? If the balloon goes straight up at a rate of 8 feet per second, again, I'm going to end up with a right triangle. I'm going to call this distance x, this is y, and this is z. If the balloon goes straight up at a rate of 8 feet per second, so it's going at the rate of, so dy dt is what? It's increasing, so it's going to be 8 feet per second. How fast is the distance from the observer, that's your observer, and that's your balloon. I'm going to write b here so you understand that, and o is for observer. Increasing when the balloon is 50 feet high. So my y is what? 50, right? And it wants me to ask this dz over dt. That's what it's asking. How fast is the distance from the observer to the balloon increasing when the balloon is 50 feet high? Okay, so what do I know? I know my x, I know my y, I don't know my z. I'm going to use my Pythagorean theorem to find that. So x squared plus y squared equals z squared. So 150 squared plus y squared is 50 squared equals z squared. 150 is, I can basically have z squared equals square root of 25,000, right? Because 150 square is what? 22500, and 50 square is 2500, so you add them, it's square root of 25,000. You can leave it in just that form, you don't have to simplify it. Okay, so now let's get to our question. It's asking me to find dz dt. So I have this equation, x squared plus y squared equals z squared. I'm going to take the derivative of it, so it's going to be 2x dx dt plus 2y dy dt equals 2z dz dt. The 2's actually cancel out as we saw it in the last question, and all I need to do is substitute in. So x is what? My x is 150, but I don't know my dx over dt. Think about it. That was your observer, and this is where the balloon, the balloon was released. Would this distance ever change? It's not going to change, so my dx dt would be what? 0 times 0 plus y is what? 50 times dy dt is 8 equals z times z is actually, we found a z, right? Square root of 25,000 and then dz dt. Okay, so 50 times 8 is 400, so dz dt is equal to 400 over square root of 25,000. I can simplify that, and I get dz over dt equals 2.530 feet per second. Yes, so that's what it is. So now the next question, it says an observer stands 700 feet away. So this is your observer. It stands 700 feet away from the launch pad of a rocket to observe a rocket launch. So this is 700. So that's my observer. That is the rocket launch happening, right? The rocket blasts off and maintains the velocity of 900. So the rocket is going up. It's going to go up, right? So my dy dt is what? 900 feet per second. Assume the scenario can be modeled as a right triangle. That's where we're getting to. How fast is the distance between the observer and the rocket changing? So I want to find this distance. Again, this is my x, this is my y, this is my z. How fast is this change, dz dt changing? Very similar to what we just did. So, but do I know, and the rocket changing when the rocket is 2,400 feet above the ground. So basically my y is 2,400. Right? So very similar to what we just did. So let's find our z. So z is going to be z squared equals 700 square plus 2,400 square. This is actually one of the Pythagorean triple. So it is actually going to be z equals, you can just solve it, 2,500, right? So I don't know if you know what triples are, 3, 4, 5, like you have a perfect triangle, right? These are your legs and 5 would be your hypotenuse. Then you have another triple, which is 7, 24, 25. That is your triple. 5, 12, and 13. That's another triple, and multiples of these of course are your Pythagorean triples. So these are the triples, and that's how I kind of got the answer. If you don't remember it, then you'll have to go all the way solving it. 700 squared plus 2,400 squared, and then take the square root of that number. Okay, so now again, my horizontal distance, or my rate of change, or my dx over dt is going to be 0 for this distance, because this distance between the observer and the rocket launch is not going to change. It's a constant, right? So what is the derivative of a constant? It is 0. So I am going to use my same equation, x squared plus y squared equals z squared. I'm going to differentiate both sides with respect to time. So I have what? 2x dx dt plus 2y dy dt equals 2z dz dt. My 2's cancel out, which we saw that in the previous questions also. Now all I have to do is substitute in. So x is 700 times 0 plus y is 2,400 times 900, and z is, what did we find for z? 2,500 times dz dt. So that would be actually, if we simplify it, dz dt would be 864 feet per second. Okay, so let's do one more, and then I'll ask you to finish up the remaining for homework. So it says a right triangle whose sides are changing has sides 30 and 40 inches at a particular instant. So again, I don't know if you noticed it, a right triangle it said, and the sides are 30, 40. I just talked to you about the Pythagorean triples. If this is 30, 40, do we agree that this would be 50? Let's again call this x, this is my y, and that would be my z. If the shorter of the two sides is increasing at 3 inches per second, so shorter is the y, so dy over dt is increasing at 3 inches per second, and the longer side is decreasing, so dx dt is decreasing, so it's going to be negative 5 inches per second. How fast is the area and the hypotenuse changing? So you want to find two things, right? So I want to find my, first of all, I found my z, so I want to find my area. So let's write down the area formula. So what is my area formula for a triangle? It's 1/2 area, uppercase A, is 1/2 base times height. Or here, my base is x and my height is h, so I'm going to replace my b and h with x times y. So now I'm going to take the derivative on both sides with respect to t, which would be what? 1/2 dx dt, and it's going to be product rule, y, plus 1/2 x dy dt. Yes, now let's substitute everything in. 1/2, I know my dx dt is -5, my y is 30, yes, plus 1/2, my x is what? 40, and my dy is what? 3. So what do I get? I get 30 times 5 is 150, and it would be -75 plus 20 times 3 is 60, which is -15 inches square per second. So my area is decreasing because of this negative, right? If you were to interpret what is happening to this triangle. Part B says, let me just do that here. The hypotenuse changing. So basically I'm looking for what? dz dt. I want to find my dz dt. So I'm going to use my Pythagorean theorem. And I'm going to take the derivative on both sides with respect to time. And that's what it will be. dy over dt plus 2z dz over dt. Again, my 2's cancel out, and I'm left with, I'm going to substitute all in. I'm going to use a different color. My x is what? 40 times -5 plus 3 times 30 times 3. 30 times 3 equals, what's my z? 50 times dz dt. This is -200 plus 30 times 3 is 90. And I get what? dz over dt equals -11 over 5 inches per second. So that's it, guys. Again, your units, they're not asking you, but it's a good practice to do. So finish up the remaining lesson, show all the work, make sure you draw pictures. That's very important because it gives you a better understanding of the question.